Okay, so we're going to start with the um, models of the hydrogen atom, specifically the billiard ball model, where the photon or the uh, light quanta, which is the fancier term for it, um, bounces off and reflects off the billiard ball model. This model didn't last long because it didn't account for any subatomic parts. Moving forward, we go to the plum pudding model. Now, down on the bottom, I have the spectrometer, which gives us an idea of what light is emitted from the atom when a photon is absorbed. So if you look here, not all the photons are absorbed that pass through the electron. Some are. The photon gains kinetic energy, then releases a photon um, when it loses kinetic energy. So when we look at this, we see a photon hit the electron, it gains kinetic energy, and when the electron slows down and stops, it emits a photon in return. Plum pudding model doesn't account for much besides just smaller subatomic parts, no specific location, they just kind of bounce around. The classic solar system model, well, besides for the simulation saying it explodes, it doesn't really account for the electron, you know, not just traveling in a circular orbit, but a probability of where it could be. And it doesn't actually create a line emission spectrum, which is really important because all atoms will absorb photons and emit photons, which moves us to the Bohr model. So while we do have the the electron traveling in a circular path, um, we can see that the electron, depending on the color of photon that